Good afternoon or good evening, class and professor. For this week's discussion, I will be going over density altitude as it pertains to a commercial pilot. So, um, this is a professional football game, and you may be wondering what does this have to do with aviation? Well, an interesting note is that all of the longest field goal kicking records are in Denver, the city of Denver. And you may be curious as to why the longest field goals have been completed in Denver. Well, it's because of its namesake. It is the Mile High City. So it's going to have a higher density altitude than every other city in the United States. And the city behind that is going to be in Phoenix, Arizona, and they're at about an elevation of about 1,000 feet. So that's why footballs and baseballs, for that matter, travel further distances in higher density altitude areas. Now, we're going to talk about how that pertains to aviation. So there's different types of altitude. So at this phase as a commercial pilot, you should be pretty familiar with the different types of altitude. So absolute altitude above the ground, pressure altitude, and true altitude. Here's an example here of a Cessna 172. This is an aircraft I have experience flying in, but in the state of Florida. So the performance I would get in the state of Florida is not going to be the same distance I'm going to get in the city of Denver, Colorado. Now, here's also an example of how temperature affects density altitude. So, as you can see, the colder it is, the greater performance you're going to have. So that means less of a takeoff roll, and your climb over a 50-foot obstacle is going to be a shorter distance. So as you see here, we have 0 degrees Celsius, and it's at 2,475 feet for over a 50-feet obstacle. Now you take that same elevation in Denver, which is, like I said, mile high, and then let's say you raise the temperature to 35 degrees Celsius, which is pretty high. And you see, not only does your ground roll increase by over 400 feet, but your climb over a 50-foot obstacle is over 800 feet as well. So what happens in this situation is you as a pilot, you need to be well aware of what type of conditions you are flying in, and also what you need to do to prepare yourself for these situations. So here's an example of a chart. Now this is your typical density chart that you're going to use, something in your POH, your pilot's operating handbook, in order to figure out what the density altitude is going to be for your area. So you put in the calculations and you use the chart, and it may tell you that your aircraft may be performing at a higher altitude than what it actually is. You see here, it's very simple. You check the air temperature, you go up to the current pressure altitude, and then you're going to add field elevation. You're going to add that field elevation, you're going to go left on the line, and that's going to be your density altitude. Boom, 6,800. Now, there's a lot of different ways to establish your density altitude. A lot of us use ForeFlight, or should I say a commercial product, in order to get our density altitude for us. Commercial products such as ForeFlight, when you're checking weather, for example, you go to the METAR and it's going to have that information at the bottom. It's pretty close and quite accurate, but there are some little differences that you're going to get from doing it that way as to doing the calculation format, in which you subtract the altimeter setting from the standard of 2,992. You multiply that by 1,000. And if you have a negative number, you subtract it from the field elevation of your airport. And if it's a positive number, then you're going to add. Another method of doing it is going to be your E6B, as we call the whiz wheel. It's basically a simple calculator used to help you determine density altitude if you do not have electronic sources, or if you think that this method would be easier or quicker than writing down the calculations. So that is my presentation on density altitude. I hope you can take this information, use it to become a better pilot. If you have any questions, please reach out. My references were the PHAT and also the Airplane Flying Handbook. Thank you and have a good evening.